Three common approaches to finding the probability of an event. This is just notation. Notation says that P denotes a probability. It would look like P of A. I want the probability of event A occur. That would be notation. Remember, we said all probabilities are between 0 and 1. Something that is 0 probability. I'm going to flip a coin. What's the probability of red? It's 0, unless the coin's red, in which case it would be 100%. And 0 is a decimal amount between 0 and 1. If I want to know the percentage, I multiply by 100, which obviously still is 0%. I have a 0% chance of getting red. If I flip a coin and I want to know the probability of getting a heads or tails, that's going to equal 1 because I have to get a head or a tail. There's no other possibility. I want to turn it into percent. I multiply by 100 and I get 100%. There's a 100% chance that I'm going to get a head or a tail. That's what this means by certain. That's what this means by impossible. Probability of some event is equal to the number of favorable outcomes divided by the number of possible or total outcomes. For example, the probability of getting a heads is equal to the number of favorable 1 divided by the number of total outcomes.
2.
Head or a tail, 1/2 is the same as 0.5. And if I multiply that by 100, I can just move my decimal place. If I want to multiply by 10, I move it to the right one. If I want to multiply it by 100, I move it to the right.
2.
0.5 is the same as 50%. And that would be right in the middle. Things that are between here and here are more likely to occur than not occur. And things that are between here and here are more likely not to occur than to occur. Different approaches to finding probabilities of an event. We have relative frequency, which is an approximation of probability. And when we conduct a procedure and count the number of times that an event occurs, the probability of A is then approximated.
As we said before, P of A is equal to the number of times A occurs divided by the number of times the procedure is repeated.
Observations are experiments. It's not based on theory. If I wanted flipping a coin 100 times and find out the probability of heads, then I have to flip that coin 100 times and count them. So relative frequency is the same as I'm going to conduct an experiment. I have the classical approach to probability. The classical probability requires equally likely outcomes. For example, flipping a coin. There's 2 possibilities. As long as it's equally likely, then we could say the number of ways A occurs over the number of different simple events. Sample space, for example, If I want to know the probability of 2 boys and 1 girl would be equal to the total number of possible outcomes, which is my sample space, which was 8, 2 boys and 1 girl, 2 boys and 1 girl, and that's it. My classical approach would be I have 3/8. I could turn it into a decimal. I can multiply it by 100, get a percentage, but this is definitely less than 1/2. It is less likely than a 50-50 chance. When using the classical approach, we always have to make sure that the outcomes are equally likely. For example, if I was gonna have a child and I wanted a girl, if it was more than 50% chance that I would have a girl, maybe it was 52% chance I'd have a girl and a 48% chance I would have a boy, then I wouldn't be able to use this classical approach because I don't have equally likely out. And then the last is subjective probability. And that's an estimate based on your experience or for example, if I said, "What's the probability that that's gonna land on a head?" You'd say 50% chance, and that is subjective. You might say, "What's the probability that your friend's birthday is in January?" My intuition says it's 1 out of 12 because there's 12 months. 1 month is January. But maybe more children are born in January than any other month. What kind of probability? Would it be classical or would it be relative? It would be relative because we would have to count. We'd have to have some information. In January, this many children were born. In February, this many children were born. And then we could say that every month we would have to use relative frequency approximation. That would be subjective.